Thank you, Martin, for those very nice slides. So I'll be talking about Piggyback Unleashed, or, I mean, that's the title that Martin chose. If you're talking to me, we're talking about distributed piggyback. Now, this might be somewhat of a room splitter. I now can't really see your faces, but maybe some of you are going, distributed what next? I'll explain. But there also must be those of you, and I know that because when we started implementing this piggyback feature, it was one of the top 3 most wanted features on the Ideas portal. And now it has arrived. So before I tell you what we actually did and how we did it and why, let me briefly recap what Piggyback actually is. We've heard it a few times already today, but nevertheless. So assume you're in this situation. You have a Checkmk site in Munich. You have 2 virtual machines monitored by the site. They are running on a vSphere node. You install the regular Checkmk agent on those VMs, and then you get these services. Now, most likely the vSphere node will be managed by a vCenter, and that vCenter might also be part of your monitoring. And if that's the case, you will get additional information on these VMs via the vCenter. Usually that would mean that the corresponding services would show up at the vCenter in your monitoring. Now, in this case, you might not want this, but you would rather want these services to appear on the VM itself, and this is what the piggyback mechanism is for and what it achieves. So far, so good. Now let's assume there was another city called Bielefeld, and you have another Checkmk site with another 2 VMs, also on a vSphere node, so same setup. But your vCenter, of course, still monitored in your Checkmk site in Munich, which means you would get these additional information on the other VMs as well, but it will not be available on that other site. So that's the thing we wanted to fix. Distributed piggyback means you get this extra white arrow that moves the information on the VMs to the remote site where it's needed. So OK, we're building this little white arrow. How hard can it be? So what do we do to do this? Well, we add another component and another component. So that might seem overkill, but I'm confident that I will explain to you why we did this and what they do. So in order to get this done, what we need is a new Intersite communication tunnel, and we have to solve a couple of problems. Usually in the regular setup, let's say, we are talking about a central site that will be able to contact all of the remote sites, but usually that's it. But we also want the other way around, and we also want remote to remote. And the problems we need to solve is we need encryption, authentication, authorization. We need to think about the routing, because maybe we want to send some messages from one site to another site that can't reach each other directly, so we might have to reroute the messages some other way. The direction of the communication might not be the same as the connection build-up, meaning you might want to send messages from a remote site to a central site, and usually communication can only be established in the other direction. And for the CME case, we also must have data segregation, so data of one customer must not be accessible to another customer. So I'll explain this. This is a simplified version of what's going on. Fear not, I'll talk you through it, and then you will see why we ended up with 2 components and what this is about. OK. Start looking at the dashed white box. This is your application. For example, your distributed piggyback feature. It might be another feature as well. Any feature that wants to send a message to some other site. So what it does is it publishes a message to the Rabbitmq instance. Sorry, I think I forgot to tell you that we settled for Rabbitmq. We evaluated a couple of possible solutions for these problems, and we ended up using Rabbitmq. They claim to be a reliable and mature messaging and streaming broker, and so far we are not disappointed. And that's how we set up Rabbitmq. Makes much more sense now, I think. OK, so this application sends a message to the Rabbitmq instance, and this is also already the first answer to the first problem. Rabbitmq instance is configured to use MTLS always, period. Whether it's locally on the site or whether it's in between sites, Rabbitmq communicates via MTLS only. So that's encryption, authorization, authentication covered. The application publishes the message to the Checkmk Intersite exchange. An exchange, don't worry, it's a thing inside the Rabbitmq instance. And that thing knows about the routing. So in purple here you can see the routing keys, and the exchange knows where the message needs to go next. It's if the site can be reached directly, it will a message for site B will go to the queue for site B, of course. But maybe we need also a message for site C needs to go via site B. In this case, it will be routed through that queue as well. So that's the routing problem covered. Now, the main reason why we settled for Rabbitmq and not for any of the other messaging brokers that there are out there is the shovel plugin that comes into play next. So next thing, we need to move the message actually from one side to the other. And that's what the shovel does. It shovels the messages over. And the important thing here is that the shovel is a plugin running in the Rabbitmq instance. And it doesn't care whether it connects to something locally or remotely. So in this case, side A can reach side B. That means the shovel is running on side A, it contacts side B, and it moves the messages over. If it were the other way around, and only side B was able to contact side A, we would have the exact same setup, but that blue shovel box would be down in side B, but nothing else would change. And of course, we always have two shovels, one for each direction, one from A to B, one from B to A. And they run on whichever side is able to contact the other side. Now the messages arrive at the other side, and if that other side notices, yeah, side B, that's me, this message is for me, it will move the message to this other exchange, meaning it has arrived at the site where it needs to be. And that other exchange will distribute it on queues belonging to the application, and the application can pick it up from there. Now that's, if you paid close attention, we have 3 of the problems covered. There's the 4th problem, the data separation for the CME case, and actually Rabbitmq brings a feature exactly for that, which is virtual hosts. So inside the Rabbitmq instances, we have virtual hosts, and messages cannot travel between virtual hosts, and that's how we can ensure the separation of the data. This is also backed by the way we choose the certificates. So sites of different customers would also never trust each other, so they really can't even try to send each other some messages. Okay, so that's quite complicated. Fear not. This is what you need to keep in mind. We have a proper separation of the business logic of the feature, which is in this case the Piggyback-hub, and the encryption authorization routing, so the general problem that we always will have if we want to send some messages from site to site. And this is what we solved once and for all in the message broker. And the Piggyback-hub only ever talks to its local message broker and does not have to deal with anything else. Now, what do we have to configure? For the business logic of the Piggyback-hub, there's only one important information. I want to have services for some host, and I need to know where does the data need to go, which site monitors the host. Unfortunately, this is already an attribute of any Checkmk host, so you don't really have to configure anything because we already have that information, and we just make sure that the Piggyback-hub actually gets the information, and that's it, nothing to do here. A little bit more noteworthy is the interaction with the DCD. The DCD, of course, never far away if we're talking about piggyback data, because it can create the hosts that are actually supposed to consume the piggyback data. Now, I don't know whether someone of you ever tried to set this monitored on-site property for a DCD connection. If you did try, you might have noticed that everything stops working and nothing happens anymore. But also, maybe you didn't care because it didn't really make any sense. You would have created a host that would have never gotten any data, so why would you do that? Now you can do that, and of course, it also actually works. And that's not trivial, because as Martin pointed out, the DCD is very quick these days, and you are creating a host on some other site, and then you're immediately discovering, and you always already want to have the data there. So we need to be very quick, get the timing right, which is what we achieved, I hope. And one important thing is here, you can't just distribute the data everywhere beforehand, like say, just in case I want to create the host over there, let's just distribute every piggyback data everywhere. That would be quite expensive, so that's not what we want to do. In fact, in the standard setup, you have to route every information via the central site, which is probably also not what you want to do, which is why there's one thing you can configure for the message broker. It already showed in the REST API earlier this morning. You can add a peer-to-peer message broker connection, meaning you can configure for the remote sites to be talking to each other directly, in which case the backend will make sure that the messages actually take the shortest path and will not be routed via the central site in this case. And there's only one thing you need to get right. We have an initiating peer and an accepting peer. As I said earlier, maybe not every remote site can establish a connection to another remote site, so you might have to get the direction right here, depending on your network. But that's really the only thing to consider. OK, so what can you do now? You can watch it. If it's running, of course, you should be able to monitor it. So we built some monitoring for it. We have two services that are created. One for the message broker itself, meaning the overall backend functionality of this intersite communication. And then another service for the feature, in this case, the Piggyback-hub, but potentially other features as well, where you can see how many queues are, how many messages are in the queue. And you can expect to see this, 0 messages. Of course, there are messages passing through the system all of the time if you are using it, but it's quite quick, and it's unlikely that when you query it for the number of messages it currently holds, it will be holding any. So you will probably see this 0 here. We conducted some load tests, and when we added about 100 remote sites and 80,000 hosts sending piggyback data all over the place to each other, we started occasionally seeing some messages in the queues. It will be deactivated by default, the Rabbitmq and the Piggyback-hub, because the message broker does require some memory, so we tweaked it significantly. It started out wanting 4 gigabytes of memory. Now it only uses about 150 megabytes. But currently, the only use case is the Piggyback-hub, and many of you will not need it. So we turned it off. Take a look at the picture. There's one global setting to turn on the Piggyback-hub. There is no configuration option to turn on or off Rabbitmq. If you enable the Piggyback-hub, we will turn on Rabbitmq, because obviously you will need it in that case. But that might change in the future. So we deliberately didn't add a switch for Rabbitmq, because at some point, maybe we will use Rabbitmq for other things, and then we will need to have it running regardless of whether the Piggyback-hub is running or not. Because there's a lot of potential ahead, and I've already today talked about that to a couple of you, and now it's even more ideas what we could use Rabbitmq for. So there's a lot of features that would benefit from a fast communication. Notification spooler basically does the same thing, so that would be a major simplification for us if we would just use the message broker for that. We could move host data between hosts. The agent registration, I don't know if you noticed, it can take some time, because basically there we also have this communication issue that you register the agent at a remote site, and then the remote site needs to wait until the central site asks it whether something has happened. And if we had a direct communication, this would be much snappier. And there are many more options that we might want to use that for in the future. And I think that concludes my talk.